Hello everyone, we are group A7 and our project is Voxiwheel, a semi-automation wheelchair kit. And our team members are Adityan S. Philip, Arjun Krishna CV, myself Dia Sebastian and Nayana Manoj. We were guided by Assistant Professor Rinsi Marinworki and Assistant Professor Agija Lakshmi for both phases of our project from the Department of Electronics and Communication. And these are the contents we have included in our final presentation. Introduction, target uses, literature review, block diagram and its explanation, circuit diagram, need metric metrics, target specification, use case diagram and sequence diagram, flow chart, components required, Gantt chart, bill of materials, expected diagram, PCB and the results, and also our achievements. Moving into the introduction, our mission was to design and develop a low-cost, easy-to-plug-in kit that can easily transform a normal wheelchair into a semi-automated one, so that this automated wheelchair could be controlled using the voice commands or the joystick. The user could select which they could easily go with. And the main objectives are improving the quality of life, because they could easily socialize and access environments like hospitals, schools, etc. with a greater ease by using these two types of commanding systems. Then the preliminary design of kit. Our main aim was to make a kit or manufacturing a kit which could be done without dismantling any parts of the normal ordinary wheelchair. And the next objective was controlling of the wheelchair, and it is done by using two methods, that is voice commands and joystick. Target users, mainly we are focusing on community and healthcare facilities so that they could provide such facilities to very needy people, and also individuals with physical abilities, that is mainly for a long-term diseases, for example spinal cord injuries, muscular dystrophy, etc. And in further, senior citizens who have faced issues according to their because of their age, and also temporary mobility impairments which is due to the surgeries or injuries or medical conditions. For the literature review, we have reviewed some of the papers. The first paper, the core paper which we have referred was the Federico Pessini's paper, which was telling us about or giving us an idea about an attachable kit that could be easily plugged into a wheelchair, and it could convert an ordinary wheelchair into a semi-autonomous wheelchair kit. And here the controlling is done using the joystick, and there is two controlling microcontrollers are used for the screen display and also the movement for controlling the movement that is acting in between the motors and the joystick. And therefore the next one we have taken the reference from J.A. Clark. He has done a paper on the project which he has done, which is a voice control mechanism or a joystick wheelchair. Here the recording commands, recognition command and locomotion control are the three steps of the voice recognition module, but the default was this voice recognition module only could recognize 5 commands at a time. Then the TKN made a voice controlled wheelchair that is completely Arduino based, and here voice customization is done initially by the installer, then for the voice capture, then voice recognition phase. So basically there are 3 phases. So then the voice control module is connected to the Bluetooth so that the whole connection with the voice control module is wireless. The next one is Harish Hamte. Here it is done on the base of it's a wheelchair which is working on the base of eye tracking and also joystick. So here the obstacle detection is done, but its obstacle detection is kind of the harder circuitry, because the Raspberry Pi such microcontrollers are used for the obstacle detection and avoiding. And next one is Islam. Then he have done design and fabrication of voice controlled wheelchair, where the voice recognition is voice recognition module is done by microcontroller unit and SRAM. So the circuitry is much harder, and some of the commands I have given. So SAMNE for moving forward, DAIN for moving right, BAME for moving left, TAM for stop moving. These are some kind of commands they have given on their project. So moving into our project, it is the final block diagram. So we have used two ultrasonic sensors over here to sense obstacles on either sides of the wheelchair and to stop the vehicle. And we have joystick and voice recognition module, V3 module, which is a completely a set of module with microphone on it, and it could be easily plug in or easily done with a microcontroller unit. And the power supply is provided to RMCS and motor driver, and this RMCS motor driver would regulate and provide correct 5-volt supply to the microcontroller unit, so that we just no need to provide an extra 5-volt power supply to the Atmega. If there is any deflection or deviation of the power supply other than 5-volt from the RMCS 2305 motor driver, you could use a 5-volt power supply, an extra fitting to the Atmega. Then we have provided a kill switch if there is any issues happen, if the commands is not received by the system or by the kit, we could use the kill switch to stop the whole working of the wheelchair. And also the kill switch acts as an on button too. And from a motor driver, there is two motors. The two motors were the DC motors, MITE and 16 set to e-bike motors. So moving into the circuit diagram, this is the circuit diagram. You could see in RMCS there is sleep, direction and PWM pin, and the sleep pins are to stop the vehicle. Direction pins are to provide the direction or giving a particular direction commands. And you could see that direction pins are shorted together and given to the Atmega, such that the two motors would given a same direction, such that a collapse would not happen. And sleep pin is also shorted and given to the Atmega, because if one motor is on the resting phase, the other two would continue the same phase. And V3 voice recognition module, there is an input output transmitter and receiver pins. It's a simple to work pin module which could receive at a time it could record 8 commands and it could obey 8 commands. Then ultrasonic sensors, joystick and the other ultrasonic sensor on other side. Then this is all about our need metric metrics. Then the target specification. Moving on to this use case diagram. First of all, the user could switch on the kit so that only user could provide further input commands to the system or the kit, and the user could choose any path, whether it's a voice recognition or a joystick movement. So if the voice is in kind of a similar voice to a normal wavelength or a normal human being's voice, or if there is a lot of variations, we could customize the voice by the help of an installer. It's a very rare case. Here with the voice recognition module, we could go for 80 commands. At the same time 8 commands could run. So 80 commands could be already stored, such that if there is 2 different voice for the user, the installer could use or utilize the voice customization phase to get into the voice recognition. Then further, will the wheelchair movements happens. So if we need to stop the vehicle, we could use whether the stop commands or the switching. Moving into the sequence diagram. Here the sequence diagram, first of all we need to switch on the kit and user need to provide input, and the kit would recognize and verify the voice whether it's the voice of the user or not, and according to the data prescribed the wheelchair, the kit would ask the wheelchair to move accordingly by the connection between the motors on the circumferences of the wheel. And if the obstacle is dictated by the kit, it would ask the control system to stop the vehicle and avoid any malfunctioning or any accidents. Moving on to the flow chart. First of all, starting the system by switching on. If the switch is not on, the system would be continue to in a rest condition. If the system is on, it would wait for the voice or joystick movement or joystick input recognition. Then in further command processing and the wheelchair movement would happen. So the components are RMCS 2305 Rhino dual DC motor, which is a 20 ampere enabled bidirectional control of two high power brushed DC motors, which would work from 6 volt to 30 volt, and here NMOS H bridge is used, and in further 20 ampere continuously for each motor without any heatsink. And next one is voice recognition module V3 Arduino compatible, and maximum 7 voice commands could work at the same time, and 80 voice commands can be stored, and it have a voltage ranges from 4.5 to 5.5. Then DC motor, e-bike my 1016 DC motor, which comes with an 11 to 25 chain sprocket as well as a 4-bit mounting bracket on the base. As this is a DC motor, it is capable of rotation in either the clockwise or counterclockwise direction by just reversing the battery polarity out to the motor, and can be speed controlled. Atmega 328P is a high performance low power consumption 8-bit AVR microcontroller that is able to achieve the most single clock execution of 131 powerful instruction due to its advanced RISC architecture. And finally the ultrasonic sensor, which used to dictate the obstacles and to let know the kit about the obstacle and stop the wheelchair. So this is the Gantt chart we have prepared. This is the bill of materials, and we have come into the conclusion about approximately 11,300 rupees for our project and for our kit. This is the inspirational sketch we have taken from the first reference of Federico Passini. This is the expected diagram we have drawn. This is the 3D diagram. This is the PCB layout and PCB design we have done. This is the final result of kit implementation. And moving into the achievements, we have participated in Smart India Hackathon, and we have selected for the next level, which was conducted by IDC in SJCT Valai, and we have given a conference paper for the KTU Tech Fest, and it was selected, and we have gone and participated in that particular event, which was done in Ahalya College of Engineering. And we have submitted YIP's our idea submission was done in YIP program. As a summary, we just need to convey that Voxiwheel is a smart wheelchair automation kit which enables smooth patient mobility. If the main problem in our locality, in between our society, is and normally anyone could not afford this automated wheelchairs simply because they are too expensive for a normal middle class family. So if you are expecting a wheelchair to be transformed into a semi-automated wheelchair that could easily maintained with voice commands and joystick, this is the project that is completely could be dependable by those people. And its fundamental objective is cost cutting, as stakeholders doesn't need to purchase a brand new one. They themselves can set up the kit on their wheelchairs. So these are the references, and thank you so much.